Okay, everyone. This is your chemical bonding video number 4. And now that we know how to determine what kinds of bonds a molecular compound has, whether they're single, double, triple, or a combination, we now need to figure out how to name covalent compounds and determine the formulas based on the names. So, in order to name covalent compounds, the rules for binary compounds, which means they just consist of 2 atoms, the first rule is that you use prefixes to tell how many of each atom there are in the compound. Here are those prefixes, and you may want to actually write these down if you haven't been writing down notes yet, because you do have to memorize these. Okay? So 1 equals mono, 2 is di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 is deca. The second part of the rules is that the second element still ends in IDE, just like you're naming an ionic compound. Now there are 2 exceptions to those naming rules. The first of which is that you should never use mono to begin a name. The second exception is to never use a double O in the name. And I'll give you some examples of how to name, but I'll also show you why these exceptions are the exceptions. So our first example here is SiF4. And if I was going to name it, the first thing I would do is refer back to my prefixes. If I refer back to my prefixes, then I know that having 1 single silicon atom means I should use the prefix mono. But if I go back up here to my exceptions, exception number 1, then I never use mono to begin a name, so I would just leave it silicon. And then the second part of my name, I see that I have 4 fluorine, so I've got to add the prefix for 4. So the second part of my name is going to be tetrafluoride. So I still ended with the IDE, but I had that prefix to tell me how many. My second example here is CO. So for my first element, it's just a single carbon. So I might be tempted to use monocarbon to start the name. But again, up here, because of this exception, I shouldn't. So I'm just going to write carbon. And then it's just a single oxygen, which means I should put monooxide. But I can't do that either because I can't use a double O in the name. So instead of monooxide, I just write monoxide. So those are examples for naming. Now, if you're going to write formulas for covalent compounds, you basically just have to decode the name, which is why you need to know those prefixes. So my first example here for you is dihydrogen monoxide. Well, when I see the prefix di, that tells me I have 2 of them. So I have hydrogen, there's 2 of them, and then mono means 1, and oxide means oxygen, so H2O. Yes, that is in fact water, which is a common name, but this is its actual name in chemistry, dihydrogen monoxide. Second example, diarsenic trioxide. Di tells me I have 2 of them, and it's arsenic, so As2. And then trioxide tells me that that's oxygen and that there's 3 of them. So As2O3. Third example, dinitrogen tetrahydride. So di tells me I have 2 nitrogen, tetra tells me I have 4 hydrogen. Simple as that. So now that we've talked about both ionic and covalent bonding, it's important that we now compare the 2, because now we are able to know what kind of bond 2 atoms are going to form. So you need to be able to predict that and name those molecules accordingly. And the best piece of information that we know to help us identify what they're going to do is in your Google form, but I will go ahead and rewrite it. It is the types of elements that each bond uses. And so this is it right here. Ionic compounds are formed from a metal bonding with a nonmetal, while covalent compounds are formed when two nonmetals bond together. So if you know if your elements are metals or nonmetals, you'll know if they're going to form an ionic or covalent bond. So on our periodic table, we can review, where are we going to find the metals? The answer is the left-hand side of the table. So anything from aluminum, basically left, is metals, except for hydrogen. So anything in the green here is a metal. Meanwhile, our nonmetals are found on the other half of the stair-step line, on the right-hand side of the table. So our nonmetals are all over here. So if you find something towards that purple region, it's a nonmetal. Over in the green is a metal. So if you're going to have an ionic bond, you're going to have a green element bonded to a purple element. And if it's covalent, you're going to have a purple element bonded to a purple element. So in the future, it will be up to you to determine whether a compound is ionic or covalent, and then to name it using the naming rules that you've learned. So right here, I've put a few examples. So Li3N. Li comes from the left-hand side of the table. Nitrogen comes from the right, so I know it's a metal and nonmetal. That's ionic, so that's lithium nitride. Hydrogen is a nonmetal. Oxygen is a nonmetal, so I know that that is covalent. Aluminum is from the left-hand side of the table. It is a metal. Sulfur is from the right hand, so it's a nonmetal. That is an ionic compound. Carbon and oxygen, both from the right-hand side of the table, both nonmetals, covalent. Phosphorus and bromine, both from the right-hand side of the table, both nonmetals, that's covalent. So that is lithium nitride. That is dinitrogen monoxide. That is aluminum sulfide. That is carbon dioxide. That is phosphorus tribromide. So, identifying whether they're ionic or covalent is very important in naming them, and we will start to mix examples, so you'll need to be able to do this. So, tomorrow in class, we will be practicing on this, but until then, maybe mark your periodic table so that you are able to identify metals and nonmetals, and will be able to do this quicker when you get to class. I'll see you tomorrow, everybody.